Okay, so our first one over here. We see the fraction bar, which tells us we have to do everything on top first, everything on bottom next. So we're going to start on top. On top of that, what do we have to do first? Okay, the parentheses. 12 times 0.4 is 4.8, right? Next, we have to 4.8 squared is 23.04. Very good. And then plus 18. 41.58. Very good. On bottom, what do we have to do first? Square root of 2.25 is 1.5. And then 68 times 0.08 is 5.44. Minus 1.5 is 3.94. Correct. And then divide 41.58 divided by 3.94. $10.5533. We're going to go to 4 decimal places for our calculations. Now we add 9.6 plus that is 20.1533. How many of you came up with that or really close to it with round off errors?
No.
Did you see where you went wrong, or?
I plus the 9.6.
Did you have the 41.58 on top?
No.
No?
That's where I screwed up right from the get-go.
Gotcha.
Yeah.
Would you square the 0.4 instead of doing the multiplication first?
No.
That's a common
No,
error.
I took the 12.
You can't see it?
Got 4.8.
That's 9.6.
That's square root of 4.8.
Oh, sure. You square rooted the 4.8?
Or I squared it, I mean.
Okay.
Yeah.
And that's
Squared it.
that plus the 9.6.
And then added.
Right. And then drop it down.
Wouldn't it be just 9.6 plus 18.54 plus 8?
No. Because that's in the fraction, so you got to do everything in the fraction first before you add the 9.6. Yep.
Yeah, that's fine.
Okay.
I didn't even see
Oh.
68 times.
Oh, you didn't do the bottom of the fraction at all. That'll do it. Yep.
That's what I was like.
Let's try number 2 here. That one looks kind of simple. Where do we start there? I'll help you with this one. 32 divided by 8 is 4. 4 plus 9.34 is 13.34. And then we got to take the square root of 13.34, which is 3.6523. Sounds about right. Yep, 3.6524 we'll call it. So that's to the 10,000s, yeah. 4 decimal places we're rounding to for now. You notice none of the numbers in our problem go past 2 decimal places, which means in our final answer, generally you'd probably be rounding to 2 or 3 decimal places. You always want to keep at least 1 decimal place beyond, or I usually try to keep 2 decimal places beyond, so that your round off errors don't build up. It's called a round off build up or a tolerance build up. I always try to keep 2 decimal places beyond what I want my final answer to be, so that when I go to round my final answer, I don't have like 4 or 5 other roundings that are within range. All my rounding is 2 or 3 decimal places beyond what I'm going to finally round to. Well, some cases you don't have a choice. You have to round off at some point. Like this one here, this would go on forever, so I had to round that square root off.
So you round the hundredths in your answer?
Most likely, since nothing in my problem goes beyond a hundredth, I would probably round my answer off to a hundredth. I mean, there's a whole discussion on significant digits. So,
Your 14.7 times 3.14, wouldn't your sig fig go to just the tenths?
that would actually only go to the tenths, yes. But we're not going to deal with significant figures right now. I'm just looking at where I would probably put my answer. And then, significant figures comes in when you're looking at physics and chemistry. You get out into the real world, a lot of times, even in engineering, when I was doing engineering work, they let the significant figures slack.
14.70.
Yeah, but I mean, the significant figures is only really important if you're doing precision work. And I know you guys are, CNC is pretty precise, but there are certain applications where it's important and certain where it's not. And we'll go over that in a couple of weeks when we talk about measurement. Generally, as a rule of thumb, you don't want to keep digits past what the inputs are. But like I said, I always keep at least 1 or 2 digits beyond that, so I'm not rounding on top of my rounding. Okay, so now I'm on bottom here. What do I have to do first on bottom? Probably the square root thingy. That's an enclosing symbol. And inside there I have another enclosing symbol. My parentheses. So inside there, what do I have to do? Divide 8.48 divided by 1.6 is what, 5.3? Or minus 3.12 is 2.18. Squared. .18 squared is 4.7524. So now we've got 43.1 plus 4.7524. Can everybody see how I'm doing this? I know I'm kind of jumbling this up to save space, but does it make sense? Kind of. This is 8.48. Yep, that's the point. Remember, notice in here, because of the decimal points, I'm using crosses for my multiplications. Yeah. Yep, you got to look and you see that, whenever there's multiplication here, they're using the X, so that means the dots are all decimal points. I would never mix the two within the same problem. So we have 43.1 plus 4.7524 is 47.8524. We got to square root that. What's the square root of that? $6.9 something. 6.9175. Okay, so that's the square root. Now we've got to do 14.7 times 3.14, which is 46.158, okay. Minus, what's that?
136.2.
Yeah, well, we're going to take it out for a few extra digits just so we don't lose information. And so we're going to take the 46.158 minus 6.9175, which is going to give us 39.2405. So now we're down to this. We're going to divide 3.6524 divided by 39.2405 gives us 0.0. What's that? 3.6524 divided by 39.2405. 0.0931. Then we square root that. .3051. Again, we'd probably end up rounding that to 2 decimal places just because there's only 2 decimal places ever used in the problem. So 0.31 would be my thing.
You go up, because I got.
We're at.
I gotta see where.
Now you brought up the idea of significant digits. We're not sure if these are measurements or not. Significant digits only apply if it's measurements. And so significant digits, what it's doing is it's taking the accuracy or the precision of the measurement device and trying to keep that true through the calculations. So every measurement has an implied plus or minus tolerance, basically, because of the measuring device. And we don't know if these are measurements. So that's why I'm saying we're going to hold off on significant digits on that. So we don't really know how they apply here. And we don't know if they apply. But at the same time, we're not going to take it out because the square root goes on forever. So we're not going to take it out to like 18 digits either. Did you figure out where it went wrong?
No. Can you scroll up a little?
Did you get the 3.6524 on top?
Yep.
Okay.
On top. And then I got on the bottom, I think I got 46.158.
That's this. Then you had to subtract what you got from the square root.
Yeah, and the square root is
6.9175.
uh,
Subtracted wrong? Okay. Okay, well, you guys had some. You have a question?
And then it comes 09307 because 091.
Yeah, it'd be 0.0931 to square root that. Yep. You don't necessarily have to put the 0 in front of the decimal point, but yes, just square root 0.0931. Okay, on the homework, you guys had some problems on roots and powers on 121. I just want to do one of each of those quick. For problem number 1, you're given the length of the side of a square and you want to find its area. The formula they give you there is that the area is equal to the side squared. So for like number 1, I'm going to do part B. The length of your side is 0.325 centimeters. The area is 0.325 squared. Which is 0.1056 centimeters squared. Now that's just rounding off. It doesn't say where to round. It says give your answers to 2 decimal points. So this would be 0.11 centimeters squared. Because they're telling you in the problem to round to 2 decimal places. Number 2 then is volume. The volume is equal to the length of the side cubed. So let's look at just C for this one. Part C, they're telling you that the side is 6.600 feet. So the volume is going to be 6.600 cubed. $287.496. This is number 2, part C. And this is saying to leave it to 3 decimal places, so we're good there. That will be feet cubed. So number 2 told you in the problem to round to 3 decimal places. Any questions so far? Number 3 then is giving you the area and asking for the length of the side. So the length of the side is just the square root of the area. We're reversing that whole process. And let's do B again. If our area is 8.76 kilometers squared, our side is the square root of 8.76. Which is 2.9. This is going 2 decimal places. 2.9597. So it's going to round to 2.96, and it's just going to be kilometers. If you square root kilometers squared, you just get kilometers. And then number 4, given the volume, the length of the side is equal to the cubed root of the volume. So if we look at letter C there, we're given that the volume is 1.896 meters cubed. The length of our side is going to be the cubed root of 1.896. So I got to do 3. Where's my X root key here? Oh, shoot. On this one, I got to do this. Math. X root 1.896. 1.2377. This one to 2 or 3? This one's saying 2 decimal places, so 1.24. And that is going to be meters, because the cubed root of meters cubed is just meters. Remember, cubed root and cubed reverse each other, cancel each other out. Any other questions? Yep. Yeah, because you get 1.2377 or 76, but it rounds up 77. Okay. Our next topic for the course, we're going to be starting in on percents. To understand percents, we have to understand the word percent. Percent is actually 2 words. Per, if you think miles per gallon, miles per hour, that means for each or out of. And cent. Think of pennies in a dollar, cents in a dollar, years in a century. That's 100. So percent literally means out of 100. So if I have 38%, that's our percent symbol, of course. That literally means just 38 out of 100. In fact, the percent symbol, that symbol, originally looked like that. It's just a generic fraction. Through the years, the squares have been rounded off to be circles and so on. But all that is that percent symbol is just saying this is a ratio or a fraction. So to convert a percent into a fraction is really just that simple. 38%, 38 over 100. Now, we wouldn't leave it as 38 over 100. What would we want to be able to do with that? We can reduce it. Both of those numbers can be divided by 2. Would give us 19/50ths. So what if I give you 65%? What's that going to be as a fraction? Start out as 65 over 100, and then what? Both can be divided by 5 to give us 13/20ths. What if I have 248%? It's still going to be just 248 over 100. Percent is always out of 100, no matter what. But that's an improper fraction. So how many times can I take 100 out of there? Twice, with how much left over? 48. Now, some people might say, well, why don't we divide by 2 or whatever? To me, it's easier to take out the whole items when you're using 100 as your denominator, because I can subtract out 100 real easy. So I got 2 and 48 hundredths, but that can still be reduced. Both 100 and 48 can divide by what? 4. Perfect. 48 divided by 4 is 12. 100 divided by 4 is 25. Am I done?
No.
What do I need to do? Got to remember the 2. Perfect. Biggest mistake I'll see made there is I'll forget the 2. So be careful with that. How about 37.5%? what's that going to become? Well, it's 37.5 over 100. Always out of 100, right? But I don't like having a decimal within my fraction. So to get rid of it, just like when we were dividing by decimals, we multiplied by 10 or 100 or whatever to move the decimal point over. We do the same thing here. It's only one decimal place, so multiplying by 10 gets rid of it. So it's now 375 over 1,000. If there were two decimal places, we would have multiplied by 100. And 3 would have been 1,000, and so on. Now here we can still reduce this. Both of those numbers can be divided by 25, or 5 would have worked. 25 is what? 15 over 40? They can still be divided by 5 again, get 3/8. How about 18 1/3%? Well, that is 18 1/3 over 100. Just like we don't like having decimals within our fractions, we don't like having fractions within our fractions either. So we've got two choices. One is we can just multiply by the denominator and make the fraction part go away. So this has a denominator of 3. If I multiplied by 3, the fraction would go away. So I multiply by 3 on top and bottom. 100 times 3, of course, is 300. 18 1/3 times 3 is 55. You make it 18 times 3 is 54, plus 1 is 55 over 3. The 3's cross cancel out. You got just 55 over 1 or 55. Then you can reduce that by 5. Gives you 11 out of 60. If you don't like doing that, multiplying to get rid of the fraction denominator, you could just divide it out. 18 1/3 over 100 is 18 1/3 divided by 100. I make that 100 over 1. 18 1/3 I'm going to make improper, so 18 times 3 is 54, plus 1 is 55/3. Times the reciprocal, so 1 over 100. I can cross cancel 55 and 100, both divide by 5, give me an 11 and 20. 11 times 1 is 11, 3 times 20 is 60. So I get the same fraction. Some of you might view one way as easier than the other. In your notes, convert 18.5% to a fraction and 36 2/3% to a fraction. So 18.5 becomes 18.5% becomes 18.5 over 100. What do we do with that? So we multiply by 10, becomes 185 over 1,000, and then we divide by 5, gives us 37 over 200. How have you got that? Good. 36 2/3%, of course, is 36 2/3 over 100. What do we do with that? Multiply by 3. Get rid of the fraction, or did you divide it out? Multiplied by 3. Gives us 110 over 300. Both of those divide by 10. 11 over 30. The 110, 36 2/3 times 3. So you got to make 36 2/3 an improper fraction. 36 times 3 is 108, plus 2 is 110 over 3. Make the 3 into a fraction by making it 3 over 1. 3's cross cancel, you got 1 and 1. 110 times 1 is 110. 1 times 1 is 1. Okay, what if we want to go from a percent into a decimal? You know, we said 38% was just 38 over 100. Rather than reducing the fraction, it's easiest to go straight to a decimal from there. To turn a fraction into a decimal, we just divide the numerator divided by the denominator. So that'd be 38 divided by 100. When we divide by 100, it just moves the decimal point 2 spots to the left. So that becomes 0.38 or 0.38. Anytime we're changing a percent to a decimal, it's going to be just dividing by 100. So we can divide it by 100 or we can just move the decimal point. So 72% is going to become what as a decimal? 0.72. 8% is going to become what as a decimal? 0.08. 310% is going to become 3.1. 2.8% is going to become 0.028. Very good. Here's the one where I get most people. 1/4% becomes,
0.0025.
there it is, 0.0025. 1/4% is 0.25%. Now I still have to move the decimal point 2 spots. One thing I talk about a lot is benchmarks and estimating. And in percents, benchmarks are actually a very, very powerful tool. 1% as a decimal, of course, is 0.01. So 1/4%, 1/4% better be smaller than that. But almost everybody says 0.25 for that on first glance. Don't feel bad if that was your answer.
I said that, I don't think that much.
Okay. I can see the little
He's
tear.
hurt. No,
I
he's
can
hurt,
see the
right?
tear
Yeah.
welling up in the corner of your eye there.
He just bottles it up.
Try myself.
That's right, let it out, man, let it out.
So if I want to go from a decimal back into a percent, a decimal can be thought of as being out of 1. 0.53 is 0.53 out of 1. We want it to be out of, a percent is out of 100. So looking at this, think of it as changing and renaming a fraction. 1 times 100 makes 100. 0.53 times 100 is 53. So it's 53 out of 100, or 53%. So changing that decimal back into a percent is nothing more than multiplying by 100, or moving our decimal point back the other way. So if I have 0.73, what's that going to become as a percent? 73%. If I have 0.6, what's that going to become as a percent? 60%. 0.059 will be 5.9%. 2 will be 200%. 3.7, 370%. Good. Changing a fraction back into a percent can be a little more difficult. Let's look at one we all know. 3/4 is what percent? 75%. If we didn't know that off the top of our head, there's a couple of ways we could have gone about it. We could have done 3 divided by 4 to change 3/4 into a decimal, 0.75, and then just move the decimal point. But not all fractions work out to a nice, neat decimal like that. So,
What if you don't have your calculator?
what if you don't have your calculator?
Yeah.
Well, then it's a lot more difficult. One way that I would do it would look like this. Set it up 3/4 can be thought of as 3 out of 4, and a percent is out of 100. And it might be easier. It's still without a calculator, there's still going to be some difficulty. 4 times 25 would make 100, so 4 times 25. So 3 times 25 is going to be 75. So 75 out of 100, or 75%. But again, sometimes figuring out what you multiply the 4 by to get 100 isn't that easy.
Right.
You know, 4 is a simple one. But what if it was like 5/8? And I want to change that into a percent, so out of 100. Well, figuring out what you're going to multiply 8 by is not simple. If you did 100 divided by 8, you get 12.5. And then you're going to multiply the 5 by 12.5. So you're going to do 100 divided by 8 times 5. Well, would it make any difference if I did 5 times the 100 and then divided by 8? Would I get the same result? Either way, I'm going to get 62.5. So what they've done is it's just a shortcut. I mean, this is the actual process. This is what you would actually be doing. But as a shortcut for solving this, they've come up with a process called cross multiply and divide. So there's always two numbers that are on a diagonal, the 5 and the 100. You multiply those. Then you divide by the third number. That's going to give you 62.5. So 62.5 out of 100 or 62.5%. Does that make sense? So let's say we have 3/7 and we want to convert that into a percent. So it's going to be blank over 100. 3 times 100 is 300. Divided by 7 is going to be 42.8571429 approximately. Approximately.
What do you cross out? Like that,
3 times 100. I multiplied the two numbers that are on the diagonal. So it's 3 times 100, and then I divided by the number that was left over on the other diagonal. So rounded off, that'd probably be 42.86%, so 2 decimal places. Now I mentioned the idea of benchmarks for like the 1% and the stuff. When I'm doing percents, I keep benchmarks in mind. Let's say I have the number 480. 10% is 10 out of 100, or reduced to 1/10. So 10% of 480 would be what? What's 1/10 of 480? Just 48, right? You move the decimal point over one spot or drop the 0 or whatever. 1% is 1 out of 100. 1% of 480 would be just 4.8. Just moving the decimal over 2 spots. With those fairly simple benchmarks, let's say I want to find 21% of 480. Well, 21% can be thought of as 10% plus 10% plus 1%, right? 10% was 48, 10% is another 48, 1% is 4.8. If I add those up, that's 100.8. That is 21% of 480. So I was able to calculate that percent without having to really do much calculation. Just all of my benchmarks. Now I realize that's a little slow. So when we get into our formulas tomorrow, it'll be a little quicker to just use a formula, but you can always use that benchmark. Now there are other benchmarks, like 50%. 50% is just half. Some numbers it's easy to find half, some numbers it's not. 480 isn't too bad. What's half of 480? 240. So there's 50%. 5% isn't too bad. 5% you can think of as it's 1/10 of the 50%, right? 24. Or you can think of it as half of the 10%. Half of 48 is also 24. So you can actually do both if you want to double check. So what if I ask you to find 46% of 480? Well, 46% is going to be a little more complex. I'm going to do 50% minus 5%. What would that be? 45. And then add 1% to get to the 46. So 50% is 240. I'm going to subtract 24, which is how much? 216. And then I'm going to add my 4.8%, my 1%. So it's 220.8. I started out with 50%. I subtracted the 5% to get down. This is at 45% now. Then I added 1% to it. Now again, 46% could be a relatively complex percent, but if I use the benchmarks, I can find it fairly easily. Now, certain ones are easier to find, like 78% would be kind of tedious here. Find 78% of 480. Well, 78%, you're looking at like 50% plus 10, plus another 10, plus 5, plus 1 plus 1 plus 1. I mean, we could do it, but it's kind of tedious. So we will look at ways of calculating our percents directly next class to speed that up a little bit.
Can you add up the one and just plus subtract?
You could, but 3%, you'd have to multiply it. Yeah, you could
You
do,
can just find.
this is 10% times 2 and whatever.
Yeah. I would-
But once if you start getting into things like 3%, 8% or whatever, then you're going to have to calculate them anyway, so you just will calculate the whole thing.
No, 80%.
80, oh yeah, do
Subtract that.
50 plus 10 plus 10 plus 10 and then subtract 1 twice. That works too.
Yeah,
Or you could have done 100% and subtracted 10 twice
Yeah.
and then subtract 2 twice. I mean, there's a lot of different ways. Remember I talked about patterns earlier in the class? Everybody's going to see a different pattern. And this is a prime example of that. I mean, this is how I built 78, but there's dozens of ways you could have built 78% with those. In your book, on page 180, in the unit exercises, 1 through 23, the odd. This is in the large book. Big book, page 180. It's in the unit exercises, 1 through 23, the odd.